There is a need to increase the electrical power output of a solar panel by designing a system that automatically orients the solar panel in a way that most favorably exposes the sun to the surface throughout the day. In this design, cardboard was used to construct the base of the design. Cardboard was also used to construct the solar panel and the connecting piece. Construction paper was used to create the blinders around the sensor, and hot glue and tape were used to assemble the whole thing. The Arduino powers the system, and the breadboard is where all the wires and where the actuator and sensor are wired into. The photosensor is used to input data that is used to move the servo. In Intro to Mechatronics, I learned how to accurately wire sensors and servos. I applied this knowledge in order to wire the final system. I also learned how to write scripts in MATLAB that would input data from sensors or output data to an actuator. For example, in mechatronics, there was a lab that had students write a script that would input voltages from a photosensor and convert the voltages to positions that could be outputted to a servo. That lab greatly influenced this sun tracking system design. The script is now run and the user inputs 30 seconds as the total time. A flashlight is used as the sun. The script outputs the sunrise position to the servo, which is the actuator in the system. After a pause, the system will now input voltages from the photosensor. These voltages are used to determine where the servo will go. Since the voltage is greater than the noon voltage range, it moved in the morning position. Now as the light source moves, the system has a servo input voltages every 2 seconds. Since the voltage is now in the noon voltage range, the system outputs the position to the servo so it moves in the noon range. As the light continues to move, the voltage will be less than the noon voltage range. As soon as the system inputs a voltage less than the noon range, the system will output the evening position to the servo. When the day is over and the timer is up, the system will output a position to the servo so it is at the sunset position. In conclusion, the solution performed as it was supposed to. One specification met was the angle of incidence between the light and the solar panel. It must be between 0 and 10 degrees. The angle of incidence for this system was 8 degrees, so it met the specification. Another specification was the solar panel moved automatically. In this system, the solar panel moved automatically to each position based upon the light source location. The servo took about a second to move from each position.